Hello, welcome to this second session on partial fractions. Now we're still on the type of partial fractions where we have distinct linear factors, which you can see there. We've got three distinct linear factors this time, so it's a bit trickier than our first video. We notice still the order of the numerator is less than the order of the denominator. We've got a linear over a cubic. Well, what we're going to do first is we are going to multiply by 2x plus 1, x plus 1, x plus 3. So we're going to multiply by the denominator of the left-hand side fraction. Just notice there that it's equivalent. There should be another line there. Let's see what happens when we do that. Okay, and that's what happens if I multiply through by the denominator. Let's have a little look. Notice you're just left with the numerator on the left-hand side. With A, the 2x plus 1 cancels out. With B, the x plus 1 cancels out. And with C, the x plus 3 cancels out. You've got to get that right. You've got to really concentrate and focus when you're doing this bit. Otherwise, the rest goes wrong. Now let's look at trying to get rid of some letters. Now, if I say let x equal -1, see what happens. Well, 4 minus 2 minus -2. If x is -1, 4 minus 2x will give me 6. So I've got 6 equals. Now, let's have a look what we lose. There's -1 there would make all that 0. -1 there would make all of that 0. So I'm just left with B. So how many B's am I left with? So we've got 2 times -1, -2. Well, let's write this out actually. This is a little bit more complicated than the last one, so I'm going to write it out. So I'm going to have B times -2 plus 1, -1, -1 add 3, 2. So I'm going to have 6 equals -2b. So B should equal -3. Right, now let's go for let x equal -3. We'll deal with the fraction last. So what do I have here? 4 minus 2 lots of -3, 2 lots of -3 is -6. So we're going to have 10. 10 equals, well, let's see what we lose first of all. So -3, we've lost everything to do with A. We've lost everything to do with B, because the -3 makes that bracket 0. -3 makes that bracket I'm pointing to 0. So we're just left with C. Let's have a look. So we've got C times 2 times -3 is -6 plus 1, -5. -3 plus 1. -3 plus 1 is -2. So I've got 10 equals 10c. C equals 1. So we're getting there. Now, finally, this is a slightly tricky one. Let x equal, can you guess? Yes, you're right. -0.5. Well, why -0.5? The last kind of bracket I want to get rid of is this one, which is there and there. If 2 times -0.5 is -1, -1 add 1 is, that's right, 0. So that gets rid of the b's, gets rid of the c's, so I'm just left with the a's. So I've got, well, 4 minus negative 2x. Half of negative 2 is negative 1. So 4 take away negative 1, we're going to have 5. Just clarify that a bit for you. There you go. 2x would be negative 1. 4 take away negative 1 will give you 5. Okay, so we've got 5 there. Now let's have a look at what we've got left. We've got a. And if we've got negative 0.5, x plus 1, well, that's going to give me negative 0.5 add 1 is going to be 0.5. The x plus 3, negative 0.5, is going to be 2.5. Forgive the decimals here. So half of 2.5, we've got a lots of 1.25. Well, 5 over 1.25 is 4. So we've got a is 4. So we're now hopefully in a position where we can write our final answer. So we've got our final answer will be 4 over 2x plus 1 minus, because it's minus 3, negative 3 there, so we do minus 3 over x plus 1, and then c is 1, so we've got plus 1 over x plus 3. So we've now put the original expression into partial fractions. Let's just have a little look at what we've done. So we had our original problem there. We've multiplied by the denominator of the left-hand side. I've done my substitutions. I've chosen those correctly to get rid of each of the letters. So when I did, for example, x is negative 1, it got rid of a and it got rid of c, because x plus 1 times a, x plus 1 times c. We just work through the algebra and we end up with that. You can substitute some numbers in to try it out if you wish. I'd be quite confident with that. Let's actually check. So we've got 4, negative 3 and 1. We can actually check that, because I've got, yep, a is 4, the mark scheme here. So here's the mark scheme, here's what you need to do. Well, yep, a is 4, go. B is negative 3, and C is 1. It kind of tells you where the method is there. Look, we multiplied through method 1. We've evaluated the constant. Well, we've attempted to, we've done the method for evaluating the constant. That's looking for a substitution. Any one of them correct, you get a mark, and you want all 3 for the 4 marks. Well, what's the point? You're going to see the point of this a bit later when we start integrating and when you do your further binomial expansion. I hope that's clear and I hope you enjoyed it. Thank you very much.